Hello everyone. Now I'm going to show how my how the newly updated motor rover with multiple sensors, which includes like one, two, three, four sensors. So this is the DHT11. So this DHT11 is for temperature sensor sensing of the shield. It's optional. If you want, you can add it. So that I kept it just so that the chips won't get heated, because the chips might get overheated due to long-term usage of the motors. And the ultrasonic sensor, if you know, you would know what it is meant for, just for object detection, and this is for edge detection. So the ultrasonic sensor is not just enough for the right side and left side, because it doesn't detect that accurately the left side and right side. So hence I have added these two IR sensors. And so for the ultrasonic sensor, I have used A0 and A1. A0 is for trig pin, and A1 is for echo pin. The purple wire goes to the DHT11. So you can see in DHT11 there is a third pin also. So it comes near the S side of the DHT11. And then there is another, the last two wires, which is the black and purple wires, are just for the IR sensors. So yeah, so now I'll just add the batteries. So the code is already uploaded. I'll show it. I'll just, before that, I'll just show you the code. So as you can see, the code is there. So there's multiple. The code is quite lengthy though, but I'll explain it quite fast. So what I have included is the new ping.h, which is for the UR sensor, and the DHT, the dependencies, as you know. So this is for the IR sensors. So I'll just move this here. So that is not required also. And then we have DHT or DHT, which will initialize these three initialize the three sensors, and this is for the motors. So DHT is a class method in C programming, I mean C++. So then we have DHT pin and DHT11, which is the pin. And then we have trig echo max underscore distance. So trigger and echo are initialized, the pins, and the max underscore distance is also defined. Then we have bool overheating is equal to false, that is for the overheating and stuff. So here we will be setting the temperature, the speed of the motors, and this is just for testing purpose, the serial monitor. And here we will initially start up the DHT.begin, which will start the DHT to sense the temperature and moisture. So then we have this float data type, which will DHT.read humidity. So it will read the humidity, and this will read temperature. So if isnan temperature or isnan humidity, this will check if any of these is not reading, then it will show the DHT11 is failed to read, so that we can get to know if it is working or not. Then we have here, if temperature is greater than 40, overheating is equal to true, and it will stop the motor so that it won't continue to overheat the motors. So then we have this void loop. In the while loop in the while loop only, but here we have, if we are in overheating, we will be continuing. So here we set it to true. So once we set it to true, if we can just type in if overheating, so currently the overheating value is true, so this loop will execute. If it is false, the loop will not execute. So then if the temperature drops, the overheating will be false, and will continue on. And then we have this UR sensor, the ultrasonic sensor. So what it does is it pings the centimeter, so it's a function in the new ping.h. And then we have avoid obstacle, which is the right down here. So this is for forward. If distance is greater than 20 or distance is equal to 0, it'll just move on forward. If not, it'll just stop the motors. uh, Void backward and void left are quite common code. I might have showed you before. So then we have void obstacle, integer distance. So what it does is, here we have a bool, left side if it is black or not. So IR dot left detects black, or boolean right black is equal to IR dot right detects black. So it's a function in it's a function which we created, which was already created in IR underscore detection and the C++ code. I'll explain that too. So uh, what it does is, it will first serial print line edge detected, so it'll just make stop the motors, delay 100, backwards distance, so this takes a parameter. So all the functions except the left and right take parameters. So then we have delay 500, right delay 500, and then we stop the motors again, and then we return so that we can proceed to the proceed to moving forward. And then we have, if distance is greater than 0 and distance is lesser than 20, then what we will be doing is we will stop the motors, and we will have a delay, and we take the motors backward, and then we call, if the distance is lesser than 10, we call this function right and left. So now I'll move on to the IR detection hedge. So if we have here IR detection underscore hedge, so we'll define these two lines define the helper file. So if you want to make our program not lengthy and less and more smaller, you can just do this. So what we do is we include the arduino.h, and we have this classes and methods. So that's all related to object oriented programming. I'll not go deep into that now right now, but I'll just tell what it basically is. So class is like a big it's like a blueprint of an object, and these private and public are all the methods in that class. And it's basically meant for object oriented programming, and this is much preferred by every programmer in the world, because it's much easier to manage with code and all and also it's used for developing games and all. And this is for meant for modular programming. So in programming languages like Python or um, Lua or PHP, there is object oriented programming. I'm not sure if PHP has or not, but yes, there is. So then we have the IR detections or CPP. So this is all C++ code. What it does, this is a class method. So IR underscore detection, this is the class, and we create the IR detection method, integer left, integer right. So left pin is equal to left, right pin is equal to right, and then we have pin mode left pin input, pin mode right pin input. So both of these take inputs, and then we have IR detection colon read left. So this is another class method, read left, and then this left detects black, right detects black. This is just for testing the value. So this is connected, as you know, the IR sensor is connected to the age analog pins. So the behavior will be different. Mine is quite different because I adjusted the potential meter to be so that the IR detection detects an object when it's close as possible towards it. So now I will just add the batteries. So what I will do is I will connect the battery to the motor shield. I mean to the Arduino. So I'll just attach this. So as you can see, both the lights are on, and now the car is moving. So it will keep moving on, and you see it can rotate, and it goes and it keeps moving on. So the edge detection also works for the car, and later on I will explain how ESP32 works in Arduino, works with Arduino 2 and its compatibility. Thank you.